So are you guys able to hear me okay? I just want to make sure before we get started. All right. So feel free to ask any questions as we're going. I won't be asking you guys questions. I'm just going to go through it, and you guys can take notes on it. The reason I'm not going to ask questions is because that'll slow things down. We got a lot to go through on this test and want to get through as much as we can. But if you are stuck, please do ask a question. I would love to answer it for you. All right, so so let's take a look at it. Once again, this may not match your test exactly, but it's the same type of question. So let's read it and then we'll go through it. So customers are entering a Walmart at this rate. So that's, you can tell that that's your rate in because the customers are coming into the store at that rate, right? Notice your units are customers per hour. That's something to kind of pay attention to for F. And we're also looking at this interval from 0 to 10. The rate at which the customers are leaving is given by this function right here. And that's also going to be in customers per hour. And then they give you an initial condition here, 0 customers at time t equals 0. All right, so write an integral function, t of x. So they want us to create a new function called t of x. So I'm going to start by labeling that. That gives the total number of customers in the store at time x. All right, so what you're going to need to do to have the total number, you don't need to, this part you wouldn't write on your test. You could, I wouldn't take points off, but the t of x represents the total amount. To get that, you need to have the starting number of people plus the net change. Okay? So the starting number of people is 0. Now some of you guys on the test might have done this. T of 0. And in this case that would be okay because the input is also 0. So t of 0 equals 0, so it doesn't matter if you put 0 or t of 0, just so long as you put the right one of those two things, you're good. So the starting number of people is 0 plus the net change. Now the net change would be the rate in minus the rate out integrated. And we start from our starting time value. Now I'm going to draw some arrows here. That's my starting y value, but this is my starting x value. They're both 0, so it doesn't matter, but you got to be careful with that. They may not be the same numbers, so you don't want to just assume that. So the starting y value is what goes here. The starting x value is what goes here. So there's that, and then the x goes here because that's the variable they've got plugged in over here. So your final answer would be that for number 1, and that's worth 1 point on the test. So it's all or nothing. And like I said, stop me if you have a question. So if you don't have a question, though, we'll keep going. Bring that back. Clear annotations. Let's move on to number 2. Now, number 2, this question a lot of people missed. This is number 2. How many people went into the store at t equals 10 hours? Now, a lot of you guys did an integral starting from your starting time to your 10 time, and that's good. But a lot of you guys put f minus g there, and that's incorrect. They're only asking for us to find how many people went into the store. They don't care about how many left. They just want to know how many people went in. So all we should have integrated here was the f function. That's it. So if you missed number 2, that's probably what you did wrong, although you might have missed another point. This is the first point, just getting this set up. Okay? The output answer, some of you guys got it wrong, probably just because you didn't put it into the calculator correctly. Let's go ahead and do our calculator here. So I need to type this thing in there, the f function. So let's do that. I'm going to switch screens here. Let's see. So y equals, right? And the function was negative 30t squared plus 300t. Don't get your negative and your minus button mixed up. It's negative 30x squared. And you guys might want to, if you can keep up, you might want to try typing these in on your calculator with us as we go, because a lot of it is, are you typing into the calculator correctly? I'm going to go ahead and type the other function in there as well, because I want to talk about that one as well. So the other function, the g function, is negative 90 plus this. So once again, that's negative 90, not minus 90, but negative 90. And then plus 4,000. Now in this case, we're going to do parentheses. 4,000. If you have just one thing, we'll leave that alone, but divided by, now that bottom is going to need its own set of parentheses. The bottom is t squared minus 14t, I think it was plus 54. So the bottom needs its own parentheses, but the whole fraction also needs parentheses. So you'll notice that I've got a double set of parentheses, one around the denominator and then another set around the entire fraction. Let me double make sure I typed that in correct. Yes, I did. All right, so anytime you have more than one thing in the numerator or the denominator, then the numerator or denominator need their own little sets of parentheses. But notice I didn't give the 4,000 its own little set of parentheses because that's just one number. Okay, but as soon as you've got two things there, you're going to want to put parentheses on it. All right? So anyway, back to our question now. We wanted to find that integral value, right? So it's going to be math 9, 0, 10, and I only want the f function. I did see a couple of you guys on your test, instead of putting f, you put y1 there. Don't do that. You want to put the function in there, which is f of x. We have to type y1 on our calculator, but you don't write that on your paper. And there you go. So we should have had 5,000 as our answer on number 2. Now that's only if you had this version of the test, right? But that's how you do it. So typing it in there. I think the biggest thing to walk away from here with that little conversation is making sure you know about where those parentheses go. All right? So getting that answer in the calculator would be the other answer. Precious, if you remind me, I can go back to number 1 at the very end. I've already deleted it, so I'll have to kind of do a little bit of work. But actually, I'm recording this, so if you want, I can just bring that up for you a little bit later. All right, let's go ahead and take a look at number 3. On what time interval is the number of customers decreasing? All right, well, how do we know what the number of customers is? At any given time. Well, we answered that in number 1, so actually here, Precious, if you want to see the answer number 1, I don't know if this was your version of the test, so it might, if it's not your version of the test, then I don't know how helpful this will be, but so in number 1 we found the number of people, the number of customers at any given time. This doesn't tell us how many people went into the store, it doesn't tell us how many people went out of the store, it just tells us the total number of people at any given time x. Now we want to know at what time was this the number of customers decreasing. So if this is the function that tells me how many people there are, the customers are decreasing when t prime, which is equal to f of x minus g of x, is less than 0. Now let's talk about what I just did there. I'm taking the derivative of t. Now the 0, it was already 0, so that's, you can ignore it. When you take the derivative of this, the integral goes away, and then the x's drop down inside. That's the second fundamental theorem of calculus. And that gives you the derivative. Now, as you guys know, a function is decreasing when its derivative is negative or less than 0. So you get 1 point for writing this fact down here, telling me that t prime of x is equal to f of x minus g of x. Now, if you included the less than 0, that's your other point. So finding the derivative and setting it less than 0 are your 2 points. Now, some of you guys might have written it like this. By taking this expression up here and just adding g of x on both sides, by adding g of x on both sides, you would end up with this. Either one of those are acceptable, but altogether it's worth 2 points. I would need to see the derivative of t, and I would also need to see that inequality. And then you would say, basically, the answer. And I'm just going to put an interval there. We don't know the interval yet, but how can we know when that happens? How do I know when the derivative is less than 0? Or how can I know when f of x is less than g of x? Well, that is the time when f of x is above g of x. I'm sorry, not above. My bad. It's below. Why is it below? Because here it says f is less than g. So when f is less than g, that would mean that if you looked at the graph, the f function would be below the g function. Okay? So let's go ahead and take a look at our graphs of these functions. And you've probably noticed that you had to adjust the windows a lot on these problems. Okay? So first of all, I know my x-axis is going from 0 to 10. As far as the number of customers goes, that's the y value. I don't know how high up we'll have to go for that. Let's just see. All right, so I'm going to go ahead and go to my window here. I'm going to change the x values from 0 to 10. And I don't know what to expect with the y values. I know we can't ever have a negative number of customers, but you could have a couple hundred customers in a store, right? So let's just go ahead and we'll start off with 100 and see what it looks like. Okay, so as you can see, it goes way off that. So I need to go much higher. So let's do that. I'm going to go a lot higher. I'm going to go up to like, maybe for the y values, I'm going to take it up to like maybe, I think 1,000 might be a bit much, but I'm kind of tempted to try that. Let's try it. Oh, that's actually pretty good. There we go. So there's my two functions. Now we need to know which one is which. How do you do that? At this point, I'm not writing anything down, but you guys might need to write down this stuff if you don't know how to do this. How do you know which function is f, and how do you know which function is g? Well, if you push the trace button, up here you guys can see that it tells you y1 is this one that has the cursor blinking on it. So y1 is this one that kind of looks like a parabola, and that's the f function. The other one is the g function. So when is the f function above the g function? So let's do green for the f function. Here's my f function. It's above the g function on that interval there. I'll make g the red one here. So on that interval, you can see that the green line is above the red line. So I need to know what's that interval. Okay? So I need to know where they're crossing. Here and here, right? So we have to do our little finding the intersection point stuff, right? So we're going to push second, calc, 5 is intersect. And so it first intersects at 6.546. And the other intersection point down here, let's see if we can get it. Sometimes if you can't see it on the screen, like the words are covering it up, the calculator may not find it, so you might have to adjust your window so you could see it a little bit better. But I think that since it's under the words. It might do it. Let's try. Okay, so it just took me right back up to here. But I think it's safe to say that, let me get rid of that. I think it's safe to say that did you just press enter, or is it enter 3 times? Oh, you push in, after you do the second calc 5, it's enter 3 times. But as you guys can see, there's no way the g function is going to go above the f here. So I think it's safe to say we go from 0 up to that point. So on the interval from 0 up to 6.546, it's safe to say that that's the interval where f of x. Oh, you know what, you guys? What this is where f of x is greater than g of x, right? That's where f of x is above. I don't know why my brain keeps doing that. So actually, we want the one where f of x is below g of x. So here's f of x, and here's g of x. So the good news is I don't have to do any extra work for that. The only difference is that f of x is less than g of x. In other words, it's below it from 6.546 up to the ending time, which was 10. So this is the one we want for our answer number 3, not this one. But you have to find those intersection points, basically, to know those intervals where they're crossing so that you can know where one function's above the other. All right, and getting the interval would have been the final point there. So on this problem, you had you get 1 point for finding the derivative of t. You get 1 point for either this inequality. Well, I think the better way to write it would be like this. You could have written this, or you could have written this for your other point. And then finally, you get 1 point for your answer for a total of 3 points on that one. Okay? So that's the first FRQ. Let's go ahead and move on into our next FRQ. All right. Number 4. So the second FRQ here says a particle is moving along a horizontal axis. Okay, you got to pay attention to that. Is it horizontal or vertical? It has a velocity, so I've given you a velocity, and here's my time interval, and then here's my initial condition. At time 0, the position is 0. All right, what distance did the particle travel on this interval here? Show the work that leads to your answer. So they want distance. Now, most people did okay on this, but on the setup, so they knew it was to find distance. I'll go ahead and write that out here. To find distance, you do the integral of the absolute value of your velocity. Now, some of you guys might have forgotten to do the absolute value. But for the most part, if you don't have the absolute value on there, you're actually finding something different, which is called displacement. But this is distance, okay? And so for that, just the setup would have been 1 point. Now we need to type this into our calculator and actually get our answer here. So let's do that. Now what I'm going to do is I'm just going to reset my calculator to take me back to a normal screen and erase everything. And you guys probably already know how to do that, but it's second plus 712. Everything's cleared. And what's cool about this is that also when you guys push the mode button, you don't have to do this, but you guys always want to make sure that you're on radians. If you're not on radians, anything involving trig, you're going to get the wrong answer. Some of you might have gotten the wrong answer because of that. Yes, second plus 712. That's right, Lawrence. Thank you for typing it in there. All right. So anyway, that clears everything out. So now, like if I were to look at my graph, it's normal again. I'm not going all the way up to 1,000 anymore. That was kind of, I would have to change that. But just doing second plus 712 resets everything. So let's go ahead and put in that function. The function is e to the power of 3 cosine of t minus 4. Now, notice that minus 4 is not in the power. That's after the power, right? So you've got to make sure you're typing these things in correctly. So we have e to the power of 3 cosine of t, or x in this case. Now, here's where some of you guys might have gotten it wrong if you didn't get the right answer, even though you had the right setup. You might have just put minus 4. But notice my cursor is still in the exponent. I need to get out of there, because the minus 4 was not a part of the exponent. Okay, so now that I've got that, we can find our distance traveled. I just want to make sure I typed the equation correctly one more time. It's kind of hard going back and forth here. All right, so now I'm going to go to my home screen, and after this it's pretty straightforward. Math, 9, 0, 2 pi. If I'm going too fast, or if you got a question, let me know. We want the absolute value here. Absolute value is math. Scroll over to num, push 1. Put the function in there, dx. Oop, put that in the wrong place, so I'm going to delete that. There we go. And getting the correct answer in the calculator would have been your second point. And anytime you have absolute value, it takes the calculator a little while, but there it is. 32.679. Let's go and check out the next question now. Get rid of number 4. Number 5. On what interval is the particle moving to the left? All right. The particle is moving to the left when the velocity is negative. Precious, no, you don't always put an absolute value. It depends. So on number 4, we were doing distance, and with distance, yes, you do absolute value, but not always. Not with these types of questions. Now, when you're getting into the area and volume questions, you can do it, but otherwise, no. All right. So the particle is moving left anytime v of t is less than 0. Now here's v of t. When is that less than 0? Now you don't have to write this part down on your test, but you can. But I'm just writing this for you. V of t is less than 0 when v is below the x-axis. So anytime my v function is less than 0, that means the graph will be below the x-axis. So once again, now we're going to go look at our graph. We might have to adjust it. I know my x values go from 0 to 2 pi, so that's nice. Those are always easy to know. The y values are the tricky ones. We don't always know how high up our function will go. But let's go ahead and graph this and see if we can find where it's below the y-axis. So I'm going to go to Window, and I'm going to change the x values from 0 to 2 pi. And then I'm going to push graph and see what I get. Okay, cool. I don't think I really need to see more than that because I just want to know when it's below the x-axis, and I can very clearly see that. It's right here on this interval. So what I need to find then is I need to figure out what are these points where it's touching the x-axis. Okay, and how do you do that? Well, you're going to push the following key sequences. You're going to do second, calc, and then it's going to be number 2 for 0. Now the way that after you do that, you're going to scroll your cursor until it's to the left of the root that you want, push enter, and then you scroll again until it's to the right of the x-intercept and push enter. And now your calculator knows to look between those two x values, between the left and right points that you picked. And you push enter one more time, and it tells you where it touches the x-axis, which is 1.090. I'm going to write that down now. We don't really need the last 0, but I guess I'll leave it. All right, and you just repeat to find the other one. So here we go. Second, calc 2. Scroll until my cursor's to the left. Enter. Scroll until it's to the right. Enter. Enter. And 5.193. And on that interval between those two things is where v of t is below the x-axis, and therefore v of t is less than 0 or negative, and that's the interval where the particle therefore would be moving to the left. Okay? Moving along. And that was 2 points. So you got 1 point for the explanation, which I'll try to bring back. This piece right here, you get 1 point for that, and then 1 point for getting the correct answer, the interval. All right, let's go ahead and take a look at number 6. All right, what is the maximum distance that the particle traveled to the right? Justify your answer. Okay. Well, that's a candidate's test question. All right. So we have our input unit is time, and the thing I'm trying to find the maximum value is of the position. When is the position farthest to the right? Okay. Now, I saw quite a few people putting the wrong function here. So you have to know what you're finding the maximum of. I want to find when the position of this particle is farthest to the right. Okay. A few people were putting the v function here. Well, then what you're going to be finding if you do that is you're going to be finding when the velocity was at its greatest value. But we don't want to find when velocity is greatest. I want to find when the position of the function is farthest to the right. So I'm maximizing the position function. All right? So that's what goes there. So that's one of the big issues I saw in this question was people didn't even realize what function's supposed to go here. It's the position function. All right. Now we got to put our numbers in there. We always put our starting time and our ending time in here, and then you put your critical values in here. Now the critical values, as you know, hopefully, are those places where the derivative of your function equals 0. So what's the derivative of x? Because I need to know where the derivative of x equals 0. Now, the position function is equal to the starting position plus the net change, which is the integral of v. So x prime is v. But that makes sense. From way back in Unit 4, we learned that the derivative of position is velocity. So this is what we learned in Unit 6, I believe it was. But back in Unit 4, I think it was, we learned that the derivative of position is velocity. So those two ideas go together. But here's your position function, and the derivative of that is simply the velocity. So now they want to know, where does velocity equal 0? In other words, where does it touch the x-axis? Well, we already found those on the last slide, right? Our graph looked like this, remember? It went from here to here. Those were the two places where it touched the x-axis. The first one was 1.09, and the other one was 5.193. Okay? Now, I don't know if I would say it's a safe move. It might be, but I don't know if I would say just take your answers from number 5 and put them in here. I just make sure that the points you're putting in there are actually the places where the velocity is touching the x-axis. That's what really matters. Okay? But in this case, it just so happens that, yes, that's right where the velocity was touching the x-axis, and we already found that. All right, so we need to find x of 0. We need to find x of 1.09. We need to find x of this, and finally x of this. And we're going to see which one ends up giving me the point that's farthest to the right. Now, here's my x function up here, right? Let me actually rewrite this a little bit so you guys can see it a little bit better. So my position function is equal to the starting position at t equals 0. My x value is 0, plus the integral of the starting time to the ending time, integration of the velocity. So that's my position function. And I need to plug 0 into that, 1.09, 5.193, and 2 pi. Okay? So that's what I'm going to be plugging into my calculator and letting my calculator do the rest of the work for me. So here we go. So, let me get out of here. I'm going to push my starting position, which is 0. Now, since it's 0, you really don't need to put it, but they're not all 0, so I don't know what test you're going to have. So I want you to be aware that you always put your starting position there, plus the integral from 0 to, now I don't need to do this first point 0 because I already know that one. X of 0 is 0. I already know that. So I'm just going to put 0 here. So let's start off with 1.09. So 0 to 1.09. That's where the number goes, up there on the top. And then we're going to put our velocity function in there. No absolute value bars this time. There you go. So that's the position at that point in time. It's 9.553. All right, let's do the next one. Now, instead of retyping that whole thing, I can just push second and enter, and it brings back the whole equation again. And all I need to do is go in backspace. I'm going to delete that out of there, and I'm going to put the new number that I want in there, which is 5.193. And then I just push enter again. So that way you don't got to retype the whole thing. Now the position of the object is negative, so that means it's to the left. 0, 1, 9. And then finally in the last one, second, same thing, we're going to push second equals, and I'm just going to go up here and delete that last interval and replace it with 2 pi to get my final spot. And that one's 5.534. And so as you guys can see, here's our max. Now you got to pay attention to what the question is asking you. Is it asking for the time or is it asking for the position? Let's go back and take a look. What's the maximum distance that the particle traveled to the right? So that they want this. That's the position. That's how far away it is from 0 to the right. They don't want the time. So you got to pay attention to what the question's asking. Is it asking for the t value or the x value? Now, Gabriel, you asked a question. We don't put the absolute value bars. That's right. So if you want a position function, you do not use absolute value bars. The only two times you're going to use absolute value bars is with distance. I know you guys might be a little confused because it says distance here, but what they're really, you have to understand what the question's asking. It says, what's the maximum distance that traveled to the right? They're asking when was its position farthest to the right. The word distance, when they say find the distance that the particle traveled, now that means that's the one you do the absolute value with, and that was number 4, I think it was. Yeah, so if it's just plain, if they're just asking what's the total distance traveled by a particle on an interval, that's when you do the absolute value bars. And Dammy, you asked, can you show me what was put for y1? Sure. What was put, I think the issue with y1, with entering at this time was, I would predict that a lot of people probably put their -4 up here in the exponent, but it wasn't supposed to be. But this is what it should look like. And Precious, you had a question there. If they asked, so here's how it would be asked. If they said, what was the farthest distance to the left that the particle traveled? If they asked you what was the farthest distance to the left, then you would say this one, Precious. Because if it's negative, that means it's on the left side. Positive means it's on the right side. These are positions, right? Think of the x-axis, right? If I told you +9, that's 9 spaces to the right. But -4, that means that's 4 spaces to the left. So 9.553 is the farthest to the right, and -4 is the farthest to the left. Oh, good question, Crystal. This is the explanation. Very rarely do they let you use tables or charts as explanations, but the candidates test is an exception to that. The candidates test is your explanation, so this table is good enough. And if you think about it, it makes sense. I mean, it has all the times, it has all the positions, and after that, it's kind of like, well, duh, this is the biggest one. So you don't really need to use words, so that's good enough. All right. So, but I guess I shouldn't say duh, because it's not really so easy, right? You have to know what is the max I'm looking for, and which does it mean right or left? And there is some interpretation in there, but believe it or not, they just accept the table as the explanation. So we'll leave it at that. All right, and it's always like that. Anytime you're doing a candidates test type question, that's how it is. The candidates test is the explanation.
Mr. Bailey?
Uh-huh. So on this one, everybody's been given a graph, and we're talking about particles again. We don't have to do the problems over. Yeah, that's correct, Callie. You don't have to redo problems that you already got correct. All right. A particle is traveling along a vertical axis. So now I'm on a vertical axis. My time interval 0 to 6. The velocity is this graph up here. And this one is touching the x-axis at 1.5 and 4. On what interval is the particle speeding up? Now, almost everybody got this question right. I was glad to see that. And even more people got the explanation right. But not as many people got the actual answer right. So let's talk about it. A particle speeding up when velocity and acceleration are the same sign. Okay, so now I'm going to highlight some stuff here. This is a graph of velocity. So anytime it's above the x-axis, velocity is positive. And anytime it's below the x-axis, velocity is negative. Now, acceleration is the derivative of velocity. In other words, acceleration is the slope of my graph of v. So a positive slope is one that slants in an upward direction to the right. So for instance, right here, we have a positive slope. Right here, I've got a positive slope, and here I've got a positive slope. And so on those intervals there, acceleration is positive. And then finally, we have acceleration is negative anytime we have a negative slope, which happens on these intervals here. So anytime they're both positive or both negative, then we've got an answer. So I'm looking for where, let's start with they're both positive. That's orange and pink. That would be like right here. So from 0 to 1. And here, which is 4 to 5. That's the only two places where I can see orange and pink together. Now, we could also have both negative. That would be green and brown. So that's right here. So that's 1.5 to 3. And I don't see any other green and browns up there. And so this is one point down here explaining to me when those things happen. And then this is the second point actually giving me the intervals. The other stuff isn't necessary to include. You don't need to color it or anything like that. Yes, Gabriel. So the other intervals would be slowing down because they're opposites. Good observation. You're right. All right. So, and by the way, Gabriel brings up a good point. There might have been one of my versions out there. I think most of them were speeding up questions, but I think one of them might have said slowing down. I'm not sure off the top of my head, but slowing down is where they would have the opposite signs. What number are we on, you guys? Can someone refresh my memory? Because I keep deleting it. We're on, it's either 7 or 8, huh? Well, I'll put 8. Can someone break the tie? Precious says 8, Crystal says 7. So we're on 8.
7. 8, my bad.
Okay, good. Now I'm happy. We got more 8s. Good. All right, so we just finished 7 and we're on 8. Makes sense. All right. A particle is traveling along. Okay, I don't need to read that again. Find the particle's position. All right, so we know how to find position, right? Now, notice we're using the letter Y for position here. So the particle's position at t equals 6 is equal to the particle's starting position at t equals 0 plus the integral from 0 to 6, these two numbers. Now my starting position is 4. So this is going to be 4 plus, how do I find the integral of v of t from 0 to 6? No, Gabriel, it's not v prime, it's just v. Just v. So, well, to do this integral, I would need to find the area under the curve from 0 to 6. So I need to find this triangle's area, this triangle's area, and this triangle's area. So this guy here, that's going to be 1.5 times 1 cut in half, which would be 0.75, I think. This guy here, 2.5 times 3, that would be, I don't know. I'm going to type it in. I want to get it wrong. Sorry. 2.5 times 3 divided by 2. This one's negative 3.75 because it's below the x-axis. And then this guy here, 2 times 2 is 4, cut in half is 2. And so we have 4 plus 0.75 minus 3.75 plus 2. And I'm just punching it in my calculator right now. And I'm getting 3. Now, for this test, this question was only worth 1 point. Why I did that, I don't know. I could have made it worth 2, but I only made it worth 1. So you really did. You could have just gotten the answer. If you got the answer, then you get full points. Okay, so that's pretty much it. If you got the right answer, you get the points. If you didn't get the right answer, no points. But yeah, the rest of them would be the same. It's just basically finding area. All right, next one we're looking at distance, number 9. What distance did the particle travel? So once again, now this time they're not asking what's the distance to the right, the max distance to the right. They're not asking what's the max distance to the left. They just want to know what's the total distance traveled by the particle. And that's this little formula we saw earlier today. And since we're on this time interval, we're just going to include the entire time from 0 to 6. Now, to do this, you're going to do a couple of things. You're still going to add together all the areas, but this time it's going to be the absolute value of all the areas. Okay, so this guy was 0.75, but we want the absolute value of it. This piece here was negative 3.75, but we want the absolute value of it. And this guy here was 3, but we want the absolute value of it. And so putting all these things together, everything's going to be positive then, right? So there's no minus this time. It's just all plus. And I'm getting 7.5 for the total distance traveled on that one. Okay. So that takes care of that one. I think that's the end of that FRQ.
Mr. Bailey?
Yes.
I have a question for my test question is a lot different than that.
Your test?
Huh?
I'm sorry. You're kind of cutting in and out. What your test was different? You said?
Yeah. Into the particle on interval 0 to 8.
Huh. Maybe we can look at it together at the end if that's okay. Because
Okay.
I'd have to pull it up to see what the issue is, what's different about it, because I'm not too sure what the difference. Huh. We'll look at it. Yeah, if you want to hang out, you can. Isarelli. We can look at it together. All right, so let's take a look at this last one here. Whew. A lot of math, you guys. All right. A lot of you guys did pretty good on this one. It's a little bit more straightforward based on what we learned. I gave you a worksheet that looked a lot like it right before. That might have helped a little bit. All right. So with this problem, you guys, what you're going to want to do is just go ahead and start off this problem right away by doing something, by graphing the functions and finding where they cross. You're going to need to do it anyway, so just do it. No matter what test you had, you need to do that. So I'm going to graph 2x plus 1 as y1 and x squared plus 1 as y2, and then I'm going to find out where they graph. And once again, I'm just going to clear my calculator here, second plus, so that everything gets reset to standard. So we had 2x plus 1 and x squared plus 1. and then push graph. And if I don't like the way my graph looks, I'll adjust it. Now, as you guys can see, that's the little sliver right there that I want. If you guys look here on the graph, I want it to look like this. They're only giving me that little piece. So I want to get zoomed in on that spot right there. Now you can just adjust the window. So that would look like it goes from x equals 0 to like x equals like 3. And y goes from 0 up to like maybe like y equals 5. You could do that. So let's do that. Window, 0, 3, 0, 5. Now I don't really like that intersection point being on the edge of my screen like that, so I think I'm going to go a little bit higher than 5. I want to go a little bit higher than that. So let's try 6. Could even do 7, live dangerously. All right, there we go. I like that better. All right, we're going to want to find where they're crossing right away. Okay, so no sense in waiting. So second calc, oh, that didn't happen the way I wanted it to. Second calc 5. One, 2, 3. 2, 5. Now we want to write down both points, the x and the y this time, because we're going to need both of them. You don't know that yet because we haven't read the instructions for the problems yet, but I'm telling you, you're going to need them, so just write them down. And then we're going to do second calc. Why am I having troubles here? Second. Nope. Still having troubles. Second calc 5. Now I want to find when they cross over here. Now, this point over here on the left, it's also on the edge of the screen. And sometimes the calculator doesn't like it when it's on the edge of the screen and it won't tell you the answer. Let's see if it works. 1, 2, 3. It does. We're good. If it doesn't work, then just maybe pull over to the left a little bit by adjusting your window. But we got it. 0, 1. All right. So we're going to want to remember those points for the rest of the problem because they're going to come in handy. So this one up here was 2, 5. And this one here was 0, 1. All right, so find the area enclosed by the functions y1 and y2. So they're asking us to find this area right here. To find the area between two functions, you integrate the difference of those two functions where you put the function on top minus the function on the bottom. Now we could tell which one's on top because they've labeled it for us. But if you want to stay safe and just put absolute value bars on there just in case you're not sure which one comes first, that's perfectly fine. Now notice I'm going to be integrating with respect to x because I'm using these functions just as they're given in terms of x, which means I'm going to go from 0 to 2. I'm going to use my x values as my limit. All right? And we'll punch that into our calculator. Now, I'm not going to show my calculator unless you want me to. If you want me to, let me know. But I think I'm just going to, we've done a lot of calculator work here, and I don't think there's anything too fancy about this one as far as nothing new to really talk about. I'm just going to go ahead and punch it in there. But if you want to see what I've typed, you're welcome to ask. I'll show you. It's just kind of a pain in the butt to switch back and forth. So I don't want to do it unless you want me to. But don't feel bad for asking if you want me to. But I'm getting 1.3. With a bar. That's it. 1 point for setup, 1 point for answer. They're all like that. 1 point for setup, 1 point for answer. Let's take a look at the next one. The area enclosed by these functions is the base of a solid whose cross sections are rectangles with heights twice that of the base, and they're perpendicular to the x-axis. All right, so I like to start off by drawing a picture. You don't have to, but this is one of those 3D pictures. What we're doing is we're going to be stacking on top of this shape rectangles where the base of the rectangles in that area between the two lines. and it's perpendicular to the x-axis, so it would be running that way. And so a rectangle stacked on there would look like that. Now the base of the rectangle is the distance between those two functions. So that would be y1 minus y2 is the base of the rectangle. And it tells us that the height is the same thing as the base, it's just that it's twice as much. Oops. So we're going to multiply it by 2. So that's the area of this rectangle, and then if you wanted to find the volume of the shape that would be created by putting an infinite number of little rectangles on there, you're going to have the integral of that from your first x value to your last x value with respect to x. And there's different ways you could have written this. This is one way. Some of you guys might have just written it this way. That's also fine. The point was is you're multiplying the y1 minus y2 by itself times 2 because the height is doubled. Now, not all the problems had the height doubled. Some of them were different. You just had to pay attention to the problem. Some of them weren't rectangles. They might have been the semicircles or the equilateral triangles that we talked about. But that's the idea. And once again, you're going to type it into your calculator and get the answer. I don't think I'll bother even writing the answer this time because it's probably not too helpful to you. But once again, if you want to see it, I can show you. Let's go ahead and take a look at the third one, or the next one there. We're on, what are we on now? It's 9, this is 10, 11. So we're on 12 now, I believe. In my opinion, number 12 was the hardest one on this page. It had the most involved stuff on it. And in retrospect, I should have made this one worth more points because some of you guys did a good thing in the beginning, but I had no way to give you points for it the way that I had the points set up, so I couldn't. I just made it 2 points like the rest, setup and answer. But in retrospect, I would have liked to have given you guys points for changing these equations into being in terms of y because that's what you had to do. So for this problem, you need to rewrite the equations to be in terms of y. So instead of using y equals 2x plus 1, we're going to minus 1 on both sides, and then we're going to divide by 2. And I'm going to use this equation instead of this equation now. And I'll call that one x1. Same thing for this guy. We have y equals x squared plus 1, but I want to get the x by itself. So I'm going to minus 1 on both sides. And then I'm going to take the square root of it. And I'm going to call that one x2. And I'm going to use that equation instead of this one. They're literally the same equation, just written differently. But writing them this way allows me to do this problem because when they're asking you to find shapes that are perpendicular to the y-axis, you need to be integrating with respect to y. And when you're integrating with respect to y, your equations need to be in terms of y, and your limits need to be the y values. So remember, my limits were, we had 0, 1 here and 2, 5 here. So this time on my integral, I'm going to put the y values on there. You might want to make a little note there. Use y values for this one, right? Now, what are we doing here? We're doing squares. So let's draw our picture here. Got my shape. I'm going to lay it down flat. I want to stack squares on here so that they're perpendicular to the y-axis. So I'm stacking them this way this time. Okay. And now in a square, the base and height are the same. So now this is, instead of y1, I'm going to call that x1. Instead of this one being y2, I'm going to call that x2. The distance between them this way is going to be x2 minus x1. The one that's farthest to the right minus the one that's to the left. That's the base of my square. And on a square, the height is the same, so we'll just square it. So now we would put that into our calculator. Now, for this problem, you would have to put these into your calculator. So for this one, I'll demonstrate it for you. But basically, we're going to have to enter this equation into our calculator, this equation into our calculator, then we'll do our integral. So this one I'll show to you real quick, just because it is a little bit different. All right, so y equals, I'm not going to delete the other ones because I know we're going to need them for the last problem, so I'm going to leave them there. But we have y plus 1 over 2. Now my calculator's not going to let me put y in here. We're still going to use x, but we know it's really supposed to be y. But it doesn't really matter. Oh, wasn't it x minus 1 over 2, I believe. Notice how I've got my numerator in parentheses because there's more than one term there. All right, next one. We have the square root of x minus 1. So here's what I want to remember. Here's my little formula that I had up. Right? I'm going to want to remember that x2, that was this guy, the parabola one. So that's going to be y4 on my calculator. And this one's going to be y3. Now I wouldn't want to write this on my paper, but I'm just writing that so we remember when we type this which one was which. All right, so here we go. Second quit. Math, integral. We're going from 1 to 5. And we're going to do parentheses. Or you could do absolute value. Let's do absolute value just so it's more common to you guys. Math, absolute value of y4 minus y3. And that needs to be squared, right? Because we're doing the area of a square, dx. And so for that one, I'm getting 0.53 with a bar on it. So that's how you would handle that one. All right, let's go back to our last question on the test. Find the volume of the solid generated by revolving the area enclosed by y1 and y2 about the x-axis. So since I'm rotating this around a horizontal axis, we're going to be integrating with respect to x, which means my limits are going to be the x values of those points of intersection 0 and 2. Now, how do we do this? Well, when I'm rotating this around the x-axis, that's going to be the washer method, because there's going to be a gap here between the area I'm rotating and the x-axis. And so when you have that gap, that's the one that looks like this, where you have your big radius minus your little radius, like that. So we need to find our big radius and our little radius. So let's do that. My big radius is the distance from the function that's farthest away from my axis. So this function right here, the y1, is farther away from the axis of rotation than the other function is. So my big radius is going to be y1 minus the axis. Now, I can see that this function is above the x-axis, so I'm going to write y1 minus the axis. But if your axis is above the function, you would do axis minus y1. But if you want to avoid that confusion, just put some absolute value bars on it. So now I can rewrite this. y1 is 2x plus 1, and the axis is 0. So my big axis will be that. My big radius, I should say. My little radius is the distance of this function from the axis of rotation. which is x squared plus 1 minus 0, and therefore that's x squared plus 1. And so all we have to do is put these two things in the places of the r, and we'll have our thing with a, oh, I forgot, on this, you need a pi out here in the front. Don't want to forget that. Don't forget the pi. All right, so we have big radius squared minus little radius squared dx. Here we go. And at that point, you'll just punch it in your calculator, get your answer, and you'll have the volume of the shape created by the rotation. Okay? And so that takes care of that. All right. So that's it for our test. We'll go ahead and stop there. Precious, what I'll do is just send me an email, and you can, I'll send you the link to this video when it's done uploading. And you could look at number 1 again if you want to see it. Does that sound like a doable plan? Okay, cool.